Okay, again, this is the continuation from the last video. This is going to be the 2018 Calculus AB test FRQ number 4. So we just did number 3. Now we're going to go to number 4. So let's go ahead and get cracking with this one. Okay, f is the function defined by this, so that's the swoopy line. R is the shaded region. Above y is equal to 3. Find the area R. Well, that's just going to be an integral. However, what we need to know is where does that integral start and stop. So let's go ahead and quickly figure out those values right there. So that would be where the swoopy thing is equal to 3. So multiply across, 6 is 3 plus 9x. Whoa, where did that 3 come from? I don't know. Get rid of that, dude. So 3x squared. I apologize for that. 1 plus x squared minus 3 divide by 3 square root. So this is -1, +1. Okay, kind of almost assume that. Alright, so here we go. What is the area of the shaded region? Well, that would be the area is equal to the integral from -1 to 1 of the top swoopy thing minus the bottom, which is 3. Alright, so I can't believe it, but whatever. Get on board with what we're uncomfortable with. This is a squared plus u squared. This is the inverse tangent. Well, inverse tangent. So this is a 6 integral inverse tangent. So that's a dirty trick of them. Inverse tangent, and then minus 3x. -1 to 1. Okay, so inverse tangent it is, I guess. Alright. Oh, wow. Okay. Here we go. So let's go with 1. So this is going to be 6 inverse tangent of 1 minus 3 minus 6 inverse tangent -1 of -1 minus 3. Okay. Man, it's been a while since I did these inverse tangents. However, thinking of what this kind of is, it was brain bubble, this kind of concept. So that usually we see it y is equal to the tangent of x. So inverse tangent would be something like that kind of concept. So where is that 1? So this is in essence the angle, and so where is a tangent equal to a 1? Well, it's where they're the same. So that would imply it's at a pi over 4. So that's what this dude is right here. This is going to be pi over 4. Gosh darn, I can't believe that this is a non-calculator question, but whatever. That's silly. Alright, so same concept right here, where if this were equal to a -1, kind of same concept here. If this is equal to -1, the angle, where is the angle that produces a -1? And then the angle would be right here, and so this is the inverse tangent, so that is going to be 6 -pi over 4 minus 3 as such. Alright, here we go. So this is what? 3 pi over 2 minus 3 plus 3 pi over 2 plus 3 Oh, I'm sorry. I messed up. This is a -1, so this is a -1, so this is a +3. I'm sorry about that. Gosh darn it, I hate when that happens. So this would be, yeah, this is a -3. I knew my spidey sense again. We're tingling. So half plus a half is a whole, -6. Gross. That is an ugly problem. Alright, ugly problem. Ugh. Moving on. Alright, next is write but do not evaluate. Okay, I can do that. An integral expression for the volume of a solid when r is rotated about the horizontal line of y is equal to 7. So let's, again, kind of take a look at that picture and figure out where the heck a y would be equal to 7. And I just moved it. There it is. So y is equal to 7 would be, ooh, sneaky, sneaky. Alright, so this is now the big radius, this is the little radius, and don't forget you have to minus the 7s. Alright, so, shoot, they don't know who they're messing with on this one. Alright, so here we go, let's set it up. So the volume is going to be pi integral -1 to 1 of the big radius, so that's 3. Don't forget, because it's now at 7, so we minus 7, square the individual piece, minus little radius, minus 7 squared dx. You don't have to evaluate it, so I'm just going to leave it be. I'm not going to touch that darn thing. Like, this is a -4, positive 16, those sort of things. But again, if I just have to write it down, if I needed to, I could plug that into my calculator if I needed to. So I'm just going to leave it. Heck yeah. All right. But I guess I bet if you like check out the answer key, I would assume that they would turn this into like a 16 or something. But I don't know. Like I'm not the boss of them. So that is the dilly there. And I know a lot of people argue about like where does this -7 go. This is a difference no matter what so if this is like f of x, for instance, I'm just going off on a tangent, don't slow down and do this on the test. If this is a difference, and so let's just give a rando value for this, like let's say that this is 3. This would be like 3 minus 7. If you're squaring it, that's going to turn into 16. Now, a lot of people is like, well, no, it has to be, you have to put it up front and minus bleep, blah, bloop. Again, this is just a difference. So if this has a value, okay, we're squaring the darn thing anyways. So riddle me this, what's the difference? So I always put the opposite of whatever it is on the back side of all of these integrals. So I don't really worry about it if that's a 3 minus 7 or a 7 minus 3. Who cares is the correct answer. All right? It'll work itself out because we're squaring it anyways. All right. Again, don't do that on the test. I'm just going off because I know some teachers are going to they get irritated. Whatever, it's my video. Make your own. All right, here we go. Let h of x be the vertical distance between x and f of x, and the horizontal line y is equal to 3. Okay. Find the rate of change of h of x with respect to x at x is equal to 2. Okay. So h of x is the vertical distance of this. Okay, so that has a height of, okay, again, this is f of x. So at 2, okay, this has a height of whatever f of 2 is. Okay, so I'm just defining it as x. So it has a height of f of x. And what is the difference between that and the line 3? So that is the difference. Okay, what is the distance? That is the distance. Okay, think of it as a positive. So, so actually, you may want to think of it as 3 minus f of x. Kind of going off on my tangent up here, but whatever. So a distance is positive. So it'd be 3 minus f of x, especially when they're talking about this too. Okay, so that'll just be a positive number. Okay, so spelling that a little bit more clearly, minus f of x, which is 1 plus x squared under 6. All right, so what is the rate of change of that at x is equal to 2? Rate of change, that, my friends, is the derivative, the rate of change. And so, again, what I'm doing is I'm running off of that one right there. And so this would be 3 goes away. And so this is going to be 3 minus 6, 1 plus x squared negative 1. Okay. So, yeah, I'm still on the camera here. So again, 3 goes away, 6, negative 2, times chain rule. So derivative of the inside, 2x. Make it look a little bit more pretty, 12x. Yeah, sure, why not? 1 plus x squared. What is that at x is equal to 2? H prime of 2. So 12, 2. 1 plus 2 squared. 24. 4, 5, 25. 25. Yeah, buddy. So that should be that. So that is the rate of change of h. So that's the derivative at 2.